Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject short range wireless communication. We're going to see basics of antenna. In this video we're going to see the important characteristics of antenna. We're going to see what is antenna impedance, what is directivity, what is gain, what is effective area, and what is received power of the antenna. And we will start with what is antenna first. So in previous video we have seen various concepts in short range wireless communication, whereas whenever we speak about wireless communication, antenna plays a very vital role, right? Whenever you want to transmit any particular signal wirelessly, you have to use antenna. So what is antenna first of all? Antenna is a device which is capable of radiating the electromagnetic waves. You can able to transmit and receive the electromagnetic waves, the EMF waves, right? And it can be an interface between a transmitter and the receiver and the propagation medium. So whenever you want to transmit a signal, you will have a transmitter, that is, you will process all the signal, you will generate the signal, you will amplify it, you will filter it, and after doing all those things, the signal has to be transmitted to the receiver through the propagation medium, which will be air in wireless communication, right? And for this signal transmission, right, from transmitter to receiver, you can able to transmit a signal only with the help of the antenna, right? So antenna can play an interface between the transmitter and the receiver, and as I said, it is capable of radiating the electromagnetic waves, right? And the very important factor in RF communication system is antenna plays a very important role, right? It is a deciding factor in any radio communication system. And the principal properties of antenna includes directivity, gain, and radiation resistance. We will see one by one. And before that, we have to know the principle of reciprocity, which states that the power transmit between two antenna is same, regardless of which is used for transmission or reception, if the generator and load impedance are conjugate of transmitting and receiving antenna impedance, which means the impedance plays a very vital role, right? Impedance matching is very, very important, either in the transmitting side or the receiving side, right? The antenna impedance plays a very vital role. So the primary concern in choosing an antenna, right, is the size. Depending upon the application, depending upon the frequency range, the size of the antenna varies, right? And the first important characteristic which we are going to see is antenna impedance. When we say antenna impedance, it is the transfer of power between the communication medium and the transmitter or the receiver, right? So whenever we say a transmitter, if we say this is a transmitter, right, we are going to transmit the signal using the antenna. So definitely there should be a perfect impedance matching between this antenna and as well as the transmitter. Similarly, at the receiving side, the antenna impedance plays a very vital role, which means this antenna impedance will be a load to the transmitter side, and for the receiver, the same antenna impedance will be the input impedance, right? And when we say impedance, you have to know about three important factors. One is radiation resistance, loss resistance, and reactance. Radiation resistance is a virtual resistance when multiplied by a square of RMS current in the antenna at its feed point, equal the power radiated by the antenna in case of transmitter, which means, understand this particular concept. We already said that antenna is capable of transmitting electromagnetic waves, right? So antenna power, right, whenever it radiates EMF waves, right, we call it as radiated power. And this antenna power can be of two. One is radiated power, another one is loss power, which can be also called as loss resistance, right? Loss reactance. You can see here that is the transmitted power delivered by an antenna should be always greater than the power radiated, which means you have an antenna, right? This antenna, consider this as an antenna. Whenever you supply current, the amount of power which you deliver, the current, right, it will absorb the current and it will radiate the electromagnetic waves, right? This radiated power by the antenna is the combination of radiation resistance and the loss resistance. As I said, it is radiated power and as well as the loss power, right? Which means the radiated power can be measured as, we have given this particular current I, which means the radiated power can be measured as I square RR. Similarly, this loss power, this loss is nothing but loss due to mismatch loss, right? And the power getting wasted. This is the useful power that is radiated, and this is power lost by the antenna. So this will be represented as I square RL. And here this is called as radiation resistance and this is called as loss resistance. And if the radiated power is more, then the antenna is capable of radiating more power, right? And obviously the loss resistance has to be very less, right? So this is about radiation resistance and loss resistance, whereas we can able to calculate the efficiency of the antenna. The efficiency of the antenna is nothing but the radiated power divided by the total power. That is the amount of power which is given to the antenna and the amount of useful power that is radiated by the antenna. So it is the radiated power divided by the total power, which is radiated power plus the loss power. That is what's given, and efficiency is into the 100. So you can understand what is impedance, and it is the factor of all these combinations, right? The three important factors, that is radiation resistance, loss resistance, and its reactance, correct? And the maximum power transfer between the antenna and the transmitter or receiver will occur when there is a perfect impedance matching, right? That is the transmitting side antenna and the receiving side antenna has to be a complex conjugate of it. The impedance seen from the antenna terminals is the complex conjugate of the antenna impedance. Impedance matching is very, very important in RF communication. Only if we have perfect impedance matching, right, the signal loss will be reduced, signal reflection will be reduced, right? And another important factor of antenna is directivity and gain, right? Directivity, we have seen what is radiated power, right? Radiated power. So every antenna will radiate and will have a radiation pattern for each and every antenna, right? Some antenna, there is one particular antenna which is called as isotropic antenna, which is to be frank, we don't have any practical isotropic antenna, but theoretically isotropic antenna is an antenna which radiates its power uniformly in all direction, right, in a three-dimensional space. That is called as isotropic antenna. So an antenna which radiates uniformly in all direction, that is called as isotropic antenna. But practically speaking, the antenna will be radiating in a particular direction very effectively, right? It will not be able to eliminate radiate power in all the direction, but it will eliminate, that is, it will radiate power in one particular direction, right? The radiation pattern of an antenna will be stronger in one particular direction and it will be lighter in other direction, right? So what is directivity here? Directivity is the ratio between the radiated power in one particular direction to the average radiated power in all direction. That is called as directivity, right? So as I said, any practical antenna, it will be radiated only in one particular, in some particular direction. And it is defined as the power density of an antenna in its direction of a maximum radiation in three-dimensional space divided by average power density. As I said, it is nothing but it is the ratio of radiated power in one particular direction where it has maximum direction to the average radiation pattern, that is average radiation intensity in all direction, right? And directivity of hypothetical isotropic radiator is 1 or 0 dB, whereas for a half wave dipole it is 1.64 or 2.15 dB, where we can represent directivity in this form, that is like the radiation intensity at one particular direction and the average intensity in all direction, right? And you can see this is the radiation pattern for a normal dipole antenna, where you can see it has a double element here. This is the direction pattern containing an antenna, and this is the 3D form where it is like a solid diagram, right? And vertical wire is an omnidirectional, that it has circular horizontal radiation pattern, and directivity will be in the vertical plane. whereas we can relate this directivity to gain. That is, the gain of the antenna is directivity times the antenna efficiency. That is, we can see there is a relationship between gain and directivity, where we can represent as G is equal to efficiency into directivity. And whenever there is minimum loss, right, there is very, very minimum loss, then directivity and gain will be equal, almost the same, right? And apart from this too, there is another important factor, which is received power. In order to calculate the received power, you have to know what is effective area and what is power density. Effective area, we can say that the capture ability of the antenna, right? We already know that antenna is capable of radiating the electromagnetic waves, right? In receiver, it can able to receive the EMF waves, and in transmitter, it will transmit the EMF electromagnetic waves. And this effective area is how effectively an antenna can radiate EMF or absorb EMF wave in a particular area, right? In the capture zone of the antenna, that is called as effective area. We can mention it as capture ability of an antenna of a given gain grows proportionally as a square of the wavelength, right? One thing you have to understand in antenna, the wavelength plays a very vital role. So what is wavelength and what is frequency? You have to understand the relationship between wavelength and frequency, right? So when we say frequency, take this particular sine wave, right? When we take this particular sine wave, frequency is nothing but number of times this wave is repeated. Number of times this wave is repeated. The cycle is repeated, right? That is defines the frequency, inverse of a time period, right? Whereas wavelength is the distance at which this particular cycle repeats, right? That is, you can see this is the wavelength of the particular signal. Whereas frequency is the number of turns, number of cycles that is repeated, whereas wavelength is the distance of one particular cycle, right? And that is wavelength. Wavelength is very, very important. Only depending upon the wavelength, the size of the antenna, right, the radiation pattern, everything is interrelated, right? And here the capture ability can be represented as A is equal to lambda square G divided by 4 pi, where GR is the received antenna gain, lambda is wavelength, and AE is effective antenna area, right? It holds both for transmitting and receiving antenna. And you got to know what is power density. Power density is, we know that directivity. Directivity is how far an antenna can radiate its power in one particular direction. Maximum radiation power in one particular direction. That is directivity, right? Whereas power density is how much of power that is radiated, right? Radiated power divided by the surface area of the sphere. That is called as power density, right? We can mention that power density as S is equal to E square divided by 120 pi. And the received power of the antenna is the combination of both this effective area and the power density. So if you go to calculate the received power, it is the combination of this effective area and power density, where you can see E square lambda square GR divided by 480 pi square. The effective antenna area has some connection with the physical size of the antenna. The size, the lambda, right, everything is interrelated, and depending upon the size, right, the effective area varies. And the short range devices are in most of the short range devices, all we need is a small size antenna, because all the short range devices are very portable devices, right? And this is about very important characteristics of antenna. Like what we have seen so far is, today we have seen basic important characteristics of antenna. We have seen what is antenna impedance, right? We have seen what is radiated power, what is received power, what is loss resistance, right? What is radiation resistance, and what we have seen what is effective area, what is directivity, what is gain, right? We still have more antenna characteristics. You will see those in next videos. I believe this video will be useful for you. Thank you, my dear students.